So chapter 4, we're going to cover transformations. And there's some typos in these notes, so I'm going to go correcting those as we go as well. So instead of doing the whole chapter on chapter 4, we're basically taking the first 3 sections, 4.1, 4.2, and 4.3, and we're going to cover the main topics from those 3 sections. So in these sections, we're going to talk about transformations. And what a transformation is basically it's some kind of a move or a change in a figure, okay, to produce a new figure. So what's going to happen is you're going to have an original figure, and then you're going to have a new figure, okay? The original figure is called the pre-image. So we might notate that, here's like a triangle. We have 3 vertices here, maybe vertices A, B, and C. And then the image is the new figure. So this is the after. Think of it as a before and an after, okay? And so the new image, it's going to be the same. I'm not really good about copying stuff here, so I'm just going to draw another one and kind of pretend that it's exactly the same, okay? And it's still A, it's still B, and it's still C. So you might say, well, how do you differentiate the pre-image, the before, from the after? Well, what we do is the before image has standard letters. The after has this prime mark. So we call it, A prime, like that. It's pronounced or labeled A prime, B prime, or C prime. So when you see the prime notation, the prime definitely talks or refers to the after, the actual image itself, which is the final image. So we have 2 kinds of transformations that we can do. There's multiple kinds of transformations, but there's 2 main categories. And the categories are a rigid transformation or a non-rigid transformation. So what a rigid transformation does is that it does not change the size of the shape. So in other words, if the original shape is a rectangle, that's a 2x4, okay, let's say 2 inches, 4 inches, and stuff like that. And I'm going to for rigid transformation, I'm going to make a change to this. I'm either going to make a translation, okay, that's one kind of change. That's also known as a slide. We're going to talk about these in more detail in a bit. I could be doing a reflection, okay, which is like a flip over some line, or a rotation, which is like a turn, right? Or a spin, can think of it as a spin, over some point. These 3, a slide, a flip, or a spin, it's going to change the orientation of the shape, but it's not going to change the size of the shape itself. So my area will still be the same, my perimeter of my shape will be the same, and my segment lengths will all be the same. Okay, so those are all going to be the same size. They're not going to change. In non-rigid motions, what's going to happen is the size of my shape is going to change. So think about when you copy and paste something, like a picture on the internet, into like a Word document or something. You copy your picture in, or you insert it into your picture, and you have your original picture, but then you grab the side and you expand it and you make it larger. Well, that would be dilation is what that's called, okay? That's the kind of transformation there, and it dilates by some kind of a scale factor, like it triples in size, or it could even go smaller. These are called non-rigid motions because notice that the segment lengths, the right side is now different. It might have started at 2 inches, it might end up at 6 inches or 1 inch. And so all of my sizes are going to change. So my area will change, my perimeter will change, my segment lengths could change. Now, we are not going to focus on non-rigid motions. We're going to focus mostly on rigid motions or rigid transformations. So here are the 3 kinds of rigid transformations that we have. The first kind is a translation, which is a slide. Basically, if you look at the picture to the right, You've got this original shape here in blue. I know that's my pre-image because notice my letters, my vertices are labeled with letters, no prime marks. And then you have the image, which is the after. Notice the prime marks, A prime, B prime, and C prime. So that's indicating to me that the original is the blue one, the pre-image is blue, and the image is red. And so what happened here is that my picture slid over. There was a slide there. Now, they do show you with the black arrows that it went from A to A prime, but we don't need to insert arrows once you understand what the letters mean. So basically, we have to determine, well, what was the change? What was the transformation that was, the translation that happened here? What was the slide? Well, notice that I started with an A value here, and I ended here. So if I just go on my coordinate plane, I notice that the shift or the slide was 1, 2, 3, 4, 5 units to the right, 5 to the right, and it went 1 unit down, 1 unit down. So remember, up, down is your Y, and to the right and left is your X's. So how would we write that if I wanted to explain that transformation? I could write it officially, and I could say, well, I started with point XY here, and I had a translation, and what happened was the X went 5 to the right. Well, to the right is a plus 5. Remember, if the X goes up, or not up, sorry, if the X goes to the right, right? If the X goes to the right, it's positive, and if the X goes to the left, it's a negative change. And in my Y value, if it goes up, it's positive, and if it goes down, it's negative. So again, in this one, I know that my X went plus 5, and then what happened to my Y? Well, my Y went down 1, so that's minus 1. So this would represent the rule for this translation. I started with an XY. Notice my XY was 0, 3. Let's do it mathematically. And my change was my X went plus 5, so 0 plus 5 is 5. And my Y went down 1, so 3 minus 1 is 2. So my A prime should have ended up at 5, 2. And notice it did. 1, 2, 3, 4, 5, 1, 2. And there it is. So you can do it mathematically by looking at the rule, or you can count on the grid. So sometimes we're going to give you the grid and ask you the rules. Sometimes we're going to give you the rule and give you the pre-image, and we're going to ask you to tell us what the image is. So you do have to, again, vocab is critical. That's the one area that I keep seeing on assessments that's a problem, is our lack of ability to, or just lack of memorization of the terms. So it's going to matter that you can recognize the image, the pre-image versus the image, and that you can recognize that a translation is a slide. So I'm going to move on now to another slide and do more examples with regard to translations. Once I follow and do those slides, then I'll come back and do reflection. I'm not sure if it's all going to read as one, so if it does, just know that we're going to go from here to example 1 before we come back to reflection. So now I'm back at rigid motion, and I'm going to talk about reflection. So everything we've talked about translation, we're now going to kind of ignore, and we're going to talk about a reflection. And so reflection is when something is flipped, okay? It is a flipped version of the pre-image. And the critical part about this is recognizing what it flipped over, right? Because I can take a shape and I can flip it over anything, like if I have a triangle that looks like this and I flip it over the y-axis, let's say, then my, let me do my pre, this is my pre in blue, and then if I flip it over the y-axis, then it's going to look something like that. I'm flipping it that way, over that. And notice that it kind of changes its orientation, where a translation doesn't. A translation, if A is in the left side, it's on the left side here. Notice here, this could be our A and this could be our A prime. And notice that the A is on the right side. And when I flip it over the y-axis, the A goes on the left, the A prime. And so I can flip it that way. I might flip it over, I might do it over the x-axis. Let's say this is A, B, and C, right? This would be B prime and this would be C prime. And I could flip it over the x-axis, which means it could end up here. And it could be something like that. I know my drawing's terrible, but this would be A prime, B prime would be all the way down here, and C prime would be there. And notice again, C went from being at the bottom of the pre-image to the top of the other image of the image itself. And so what it flips over matters. And so with a reflection, you have to pay very close attention to the line of reflection. Now, we can figure out where the new graph goes by counting from that line of reflection. In other words, if I'm given this pre-image here in blue and you ask me to reflect it over line M, notice this is the line of reflection. It's reflecting over this line here. Okay, so this is the line of reflection. It's the line of really y equals 1, or line M as they call it here. So if it flips over that, I know that the new points have to be equidistant from the line. So in other words, point A in the pre-image was 2 units above the line, which means if I'm flipping it over that line, point A or A prime has to be 2 units down. B is 1 unit above it, so B prime is 1 unit below it. And C is on the line, and so C prime will also be on the line, and then I can draw my reflected shape. So it's great, you can count, and reflections are pretty easy. It's a little bit more challenging when you reflect it over a diagonal line, like, for example, here's a little chart, this one here, the line of y equals x, that's a diagonal line that goes through the origin with a positive slope, and this is a diagonal line that goes through the origin with a negative slope. And these are a little bit harder to do. We'll get to those and we'll do them. But if you happen to flip it over the x-axis or the y-axis or those origins, if you don't want to have to count, there are some ways to memorize where the image will go depending on the pre-image. So for example, if the pre-image has point A of AB for all of these, right? Let's just, and I'm not even going to say AB, I'm going to say, give you a number. I'm going to say 3, 4. So I'm going to make the original ordered pairs for all of these. This is just a single point, 3, 4, single point, 3, 4. And if it's reflected over the x-axis, okay, they say in the x-axis, I like to say over the x-axis, but the A prime would be, there's a formula, A opposite B. So what it's saying is whatever the x value is, it's going to stay the same, and whatever the y value is going to be the opposite of it. So instead of counting where A prime ends up, I know that it's the same A and B, the same x and y, except the y is opposite what it was. So if it's reflected over the y-axis, it means that I'm still going to have the x and the y in that order. I'm just going to make the x opposite of what it is. So if it's positive, it becomes negative. If it's negative, it becomes positive. And then I don't have to count. If it's reflected over the origin in a positive slope, right, I know that, notice that my A is 3, 4, my A and B, my A is 3, my B is 4, but my point A has those coordinates. My A prime is going to have the x and the y are going to switch places. So they're going to stay the same as they are, positive for both in the original, but they're going to switch their places. And if I have a line, if it's reflected over a negative slope line over the origin, so it's like this. Here's my original. This is the line of y equals x, and this is the line of y equals negative x. So it's this negative slope line. If I'm reflecting it over that, okay, then my A and my B, or my X and my Y, are going to switch places, and they're also going to switch signs. So 4, 3, and they're both positive, so they're going to become negative. And so again, you can memorize these. I find these harder to memorize. I would probably memorize these two. And then I would just count for when it's reflected over the X or the Y axis. So again, that's a reflection. Let's go to the next slide now, and let's do the example for reflection in example 1. So now that we've done the reflection, then we're going to kind of talk about rotation. So by now you should have done translation, example 1 and example 2. You should have gone and done reflection, example 1 and example 2, and now we're focusing on rotation. And a rotation is when you take an original pre-image and you spin it or rotate it around some fixed center or fixed point, okay? And that fixed point is your center of rotation. So you can rotate something over its own center. So it might be like, let's say I take this rectangle, terrible rectangle, I'm sorry, but I rotate it over its center. So if I rotate it, let's say 90 degrees, we always go counterclockwise. So if I do that, then it's going to end up, well, let me do it in blue first, right? Here's blue. Right, here's A, B, C, and D. And if I rotate it 90 degrees, my after is going to look like this, kind of. And I'm going to have B prime, C prime, A prime, and D prime. If I do it 180 degrees, I do a half turn, and it's going to look different. So what matters is, what am I rotating it over? Am I rotating it over, is its center itself? Or am I going maybe to a graph? And maybe I'm, here's a coordinate plane here. And maybe my rectangle is here. And I'm rotating it about the origin. And if that's the case, a 90-degree rotation would put it over here somewhere, okay? A 180 would put it over here, and a 270 might put it back over here with all my letters. Let's say this is A, okay? This would be my A prime for a 90 degree, right? This would be A prime for a 180, and this would be my A prime way down here for a 270. So again, the degrees matter. So you constantly, again, have to be very careful with what is your pre-image and what is the rotation degree. And on top of the rotation degree, what is, so we need to know the image or the pre-image, we need to know the rotation degree, and we need to know the point of rotation or the center of rotation. Are we rotating it over itself? Are we rotating it over the origin or some other strange, point? Most of the time we focus on 90s and 180s. Those are pretty popular. We don't do 270 too often, but again, you have to be ready to do them all. Now, again, there are formulas, okay? So if I'm rotating something 90 degrees and its original point is 3, 4, I know that the rotated issue, notice what happens. My X and my Y are going to change places, right? Whoops. My X and my Y are going to switch places. And my X is going to become opposite of what it was. So I know that a rotation of 90 degree will put A prime, let's say, at negative 4, 3. A 180 degree turn is going to put my A prime, basically notice my A and my B stay in the same spot, 3 and 4, but they both become opposite. So negative 3, negative 4. And a 270 degree rotation will put my A prime at, notice, my B and my original B and A switch spots, and my A becomes the opposite of what it is. Now these, unfortunately, I think you should have to memorize these, because these are harder to draw. Reflections are easy to count, so memorizing is not as essential, but rotation is essential. So I would say these 5 you probably have to memorize, okay? And again, now we'll continue. We're going to go to example 1 and example 2, and we're going to focus on rotation. So now we're here at example 1, and I want to talk about translation. So I'm going to do the translation part first. So when it comes to translations, first of all, this whole slide is a little bit off because it's identify the transformation is what this is supposed to say, because there's 3 different transformations in these pictures, and then write a rule for the transformation, okay? So I'm looking here at 1, 2, and 3, trying to find which one represents a translation, the one we just did, and it's example 2. So this is a translation. This original triangle, the pre-image, just slid or shifted to the left or right or up or down. Now, again, to be able to write a rule for the translation, I need to know what my pre-image was. And I know that my pre-image is this blue one, and this is my image. This is the end result. So I started at the pre-image blue, and I ended at red. How did I know that? Because notice that my variables in the red one have the prime mark. So they're the after. So what kind of change occurred? What was the rule of the change that occurred to go from the pre-image to the image? So again, I started with x, y, and my change was, let me see, what happened to my x and what happened to my y. So I can just take my, my pencil, whatever, I can pick a point, I can pick the initial m, and I can figure out, well, what change happened from m to m prime. Well, I know that I went to the left 1, 2, 3, 4, 5 units. So that's -5. And I went up 2 units, which means that's +2. So x minus 5 and x plus 2 is the rule for this problem. So it's a translation, and that's the type of transformation that it is, and the rule is that it was left 5 and up 2. And I can double check it with the other ones. I can go to n and do the same thing. 1, 2, 3, 4, 5 to the left and up 2. So that one worked as well. And so all of them, you'll see, will have that same relationship. And so that's how we do it this way, okay? Now I'm going to stop this slide, and I'm going to go to example 2, where I'm going to graph a translation from scratch. After that, I'll go back to the slide with the definitions, and we'll start talking about reflection. So I come over to this one, and I look to see which one of these is a reflection, and I notice that it's number 1. So this is definitely the reflection. I notice that in my pre-image in blue, I start with A, B, and C, and I notice that in my image, which I have here in red, they give me these weird letters, E, D, and whatever, but E is really B prime. D is really A prime, okay? And F is really C prime. And I like to stick with the same letters. I don't know why we changed the letters there. So if I really notice, I'm like, okay, where is, I'm going to start with, for example, point B. And I see that it's 1 unit over from the y-axis to the left, and the prime is 1 unit over to the right. So it is equidistant from the y-axis. That's how I know it's a reflection in the y-axis. And again, you can say over the y-axis if you want. But I know that this y-axis is definitely the reflection line, okay? And so now, that's really all that I have to do is just state the transformation, and the rule is that it's over or in the y-axis. I don't really have to do anything else. If I only gave you the blue picture and I asked you to reflect it over the y-axis, again, how you would come up with these prime marks, again, would be to count. So if B was 1 unit to the left, B prime is 1 unit to the right. If A was 2 units to the left, A prime would be 2 units to the right. If C is 2 units to the left, C prime is 2 units to the right. So drawing it is just easier. However, remember also that the other way to tell, again, notice here, A is -2, -1. And remember that when you reflect it over the y-axis, you have a formula for it. A prime is going to be the opposite of the x that you have, and it's going to be the same y. So 2, -1 is going to be my A prime. So mathematically, you can also do it using the formula, although I would recommend just counting. I think the formula can be confusing. So that's, again, an example of reflection. And now I'm going to advance to the next slide, and I'm going to show you how to reflect the triangle that we did before. So in example 1, number 3 is a transformation that shows a rotation. Okay, and so how do I know that? Well, there's a few things that help me to know that this is a rotation. First of all, this arrow. So it's showing me that this is a counterclockwise rotation. Now, what I need to do is sort of figure out the rule, which is going to tell me it's rotating around what point, right? And what is the degree of the rotation. And so, you know, obviously I have a little bit of practice with this, and so most of the rotations that we're going to do, we're going to have it, it's a rotation about the origin, okay? Or we can think of it as the center, let's say, of rotation or something like that. The center of rotation is 0, 0, okay? So now we have to think of what is the degree of that rotation. There are a couple ways of doing it. What I say is for this one is the memorizing, okay? So here's our center of rotation. Let's look, for example, at point R, okay? And we see that the pre-image has an R value of 1, 2, 3, 1, okay? And we see that the image, which is after, right, after the transformation or after the reflection, we see that R prime is located at +1, -3. So think of this again as AB, and what happened is A and B swapped places, and the A became the opposite. And so we're like, okay, well, what rotation from that last example on that slide, the rigid slide, when A and B change places, we know that that's either 90 degrees or 270-degree rotation. Well, when they change places and B becomes negative, that's a 90-degree rotation. When they change places and A becomes negative, that's a 270-degree rotation. So this is 270-degree rotation. That's the rule. So the center is 0, 0, and it's a 270-degree rotation, okay? So again, I think it's valuable that you memorize those rules when it comes to rotation and when it comes to reflection about the origin, okay? So there was a couple that you had to memorize, and I think these would be great examples of it. So again, now we're going to go to example 2, and we're going to focus on the rotation of it. So here in example 2 now, we're going to do the translation, which as you can see is example number 1. So if my original P value, notice it's telling you that you have a triangle. For all of these, we have a triangle. The pre-image has a vertices of P of -2, 3. It had a vertices for point Q at 1, 2, and it has a vertices for R at 3, -1. Now, mathematically, I can figure out what my image is going to be because the rule has been given to me here. So I need to find P prime, Q prime, and R prime. And it's easy to do because for my x's, I just add 4 to them. So -2 plus 4 is +2. Q plus, 1 plus 4 for point Q is 5, and for point R, 3 plus 4 is 7. So I know that these are my x values of my final image or my image. And then I'm going to do the same for my y values. So my y goes down by 2, so 3 minus 2 is 1, 2 minus 2 is 0, and -1 minus 2 is -3. So guess what? These are the coordinates of my image or my after. So on your slides, I think you have another slide that happens to have a coordinate plane or 3 coordinate planes to graph these. I don't have that here, so I am just going to have to graph this on my own. Okay, so let me see if I have a template or something that I can use here. Yeah, I'm not really sure how to do it. I think there's somewhere where I can get a gridded page, but again, it's not a major deal. I'm basically going to draw, you're going to have your graph on the other page, and you're going to graph your original. Now I'm going to do my pre-image in blue, just like they did in the other one. So you would go to your coordinate grid. You'd have to be very careful that you graph correctly, right? Your points. So negative 2, 3 is my first one, so that would be P. Q is 1, 2, which are like here. That's Q. And 3, negative 1 is about here. And so my original shape looks something like this, okay? And then I know that my image, so my pre-image is in blue, my image is going to be in red, and I come over to my graph and I do, 2, 1 is here, so that's P prime. 5, 0 is going to be my Q prime, and 7, negative 3 is going to be right here somewhere is my R prime. And you notice that again, obviously this isn't a great graph, but that's about right. And you'll be able to do it on your graph, and it'll be obviously better, but I've labeled it correctly. My pre-image has regular letters, my image has prime, as it should, and I show my translation. Okay, so these are all the examples with regard to translation. At this point, I'm going to go back now to the video, to the slide with reflection, and we're going to start talking about reflection. So now, again, here, they're telling us that we have that same triangle. We have the same p-value, negative 2, 3. We have the same q value, 1, 2. And we have the same r value, 3, negative 1. And they're telling us to reflect it over the x-axis. Again, over the x-axis. That means, if you remember the formula, your p prime, your q prime, and your r prime are going to be based on changing something there. When you reflect over the x-axis, your x value stays the same for all of them. Your y value becomes the opposite. So instead of plus 3, it's minus 3. Instead of plus 2, it's minus 2. And instead of minus 1, it's a plus 1. And so those are the coordinates of my image after the reflection. So again, I'm going to come over to here. I'm going to try to carefully erase this one that I did that was a translation. I'm going to keep my pre-image because that didn't change. And now I'm going to try to draw this for you guys, okay? Again, you have it better because you are going to have it on a coordinate grid on your slides. So again, if I'm reflecting over the x-axis and I'm just doing it by counting, I know that point P is 3 units up, which means P prime is going to be 3 units down. So it's going to go to here, okay? Q was 1, 2, so I know that's 2 units above the x-axis, so I'm going to go down 2 units to Q prime. And then my, this was R here, right? This is R in blue, the original. And my original R was 1 unit down, which means my new R is going to be 1 unit up. So I know my graph is a little terrible here, but that should be the reflection of the graph over the x-axis, okay? And again, I have it mathematically, and I also have it by counting. And you really do have to pick which method you prefer, okay? So these are the 3 examples of a reflection, what it is, the slide, and the example 1 and example 2. And now we're going to go back to the slide on rigid motion, and we're going to talk about a rotation. So again here in example 2, we're back to this original problem now. I'm going to rewrite it a little bit now because it's really gotten pretty messy at this point. So let me just kind of redraw the original graph here. So I'm going to graph the pre-image, which again, point P is at -2, 3. P, -2, 3. I've got Q at 1, 2 here. And I've got R at 3, -1 here. And I'm going to draw my triangle. And that's a terrible triangle. I do apologize, but it's good enough, right? So here's my triangle. And now they're asking me to rotate it 180 degrees about the origin. So again, my origin I know is coordinate 0, 0. I'm doing it 180 degrees. So if I go to the slide again, it talks about what the change is. If it's 180 degrees and you start with AB, okay, if you rotate it about the origin 180 degrees, it's going to be the opposite of A, and the opposite of B is going to be your new point. So that being said then, again, if my P is -2, 3, my Q is 1, 2, and my original R is 3, -1, then I know that I can find my, let me do it in red, my P prime, my Q prime, and my R prime just by applying this formula. So again, A and B are going to stay in the place. So this is a 180 degree rotation, but my X and Y are going to swap signs. So it's going to be the opposite of -2 and the opposite of +3. It's going to be the opposite of 1 and the opposite of 2. And it's going to be the opposite of 3 and the opposite of -1. And so that's going to be my rotated shape. My P prime is going to be located at 2, -3 here. My Q prime is going to be -1, -2. All right, so Q prime. And my R prime is going to be -3, +1. And so this is my rotated shape at 180 degrees. And so again, I think this would be very, very difficult for you to do if you tried to do this by counting and moving 90 degrees. It's much, much simpler to just memorize what the rotations do, okay? So again, the rotation, one more time, if it's 90 degrees and you start with A and B, it's going to become B and A are going to switch places, but the B is going to become the opposite, okay? If it's 180 degrees and you start with A and B, the rotated shape or the image at the end is going to be -A and -B, or opposite A, opposite B. And if it's 270 and you start with an ordered pair, it's going to switch places, B and A, but the A is going to become the negative. Again, 3 things to memorize. We're not going to ask you any other kinds of rotations, so you don't have to memorize any other ones. With the rotations, it's going to be one of these 3 that we're going to give you, and if you memorize this, it's super, super easy. This slide pertains to your homework for this section, and I'll be going over that in class, and if I need to, I'll make a separate video on this. I actually don't think this slide is in your presentation.